Good morning, dear learner. I welcome you today in the next discussion. Today we are going to cover the anatomy of aircraft and aircraft access systems. In previous lectures, I have already given you an introduction about what is an aircraft, right, and what are the different forces required to make an aircraft to fly. Like we have defined the lift, we have defined the drag force, and also we have defined basic definition of the lift based on two methodology based on pressure difference as well as based on the circulation. You have been introduced about the airfoil, what is an airfoil and which kind of airfoils are. Still today again I will discuss it in detail. So let's start with the anatomy of aircraft. So if you look at the aircraft from top and side view, the schematic diagram would be something like this. This is the top view of the aircraft, right? If you look at the top view of the aircraft, you find this kind of diagram, schematic diagram in your mind. So this is the central body, which is here. This is central portion. The central portion is basically known as fuselage. This is known as fuselage. So fuselage is the portion, or it is the part to which all the subcomponent or main component of the aircrafts are attached. The central body is known as fuselage. And this portion, which is here, this is known as main wing. So main wing is responsible for creating 90% of the lift to make your aircraft fully airborne. Now if you look at some kind of structure would be available at the tail side, which is here. This is known as horizontal stabilizer. This is horizontal stabilizer. Alright. Then if you look at the front, this is known as nose, right? Nose of aircraft, and just next to the nose, this portion, right, you will find cockpit. So cockpit is the area where your pilot used to be seated, and all the control panels will be installed in the cockpit. From there, pilot will control all the subcomponents of the aircraft to make the aircraft fly. This vertical, here you will find one vertical tail. Usually we say this complete vertical tail and horizontal stabilizer as impedance. Right, impedance is known as vertical and horizontal tail combination is known as impedance. If we look at the detailed view of the wing, right? So if you at the wing, you are seeing this kind of movable control surfaces are present. So the control surface which is nearest to the tip, this is the tip of the wing. So nearest to the tip, this control surface is known as aileron. Right? I will tell you what are the functioning of all these control surfaces later on. First we will name them. So this is the aileron. The inner portion, inner control surface, movable control surface is known as flap. Right. So we can say right wing and left wing. Right aileron, right flap, left flap. Right. Apart from that, if you come to the horizontal stabilizer section, which is here also you will find one movable control surface, which is here. It is known as elevator. This is situated at the horizontal tail. Right. So this is known as horizontal stabilizer. Over a horizontal stabilizer, you are getting control surface, which is the elevator. At the wing, you are getting aileron, flaps. Right. Apart from that, there will be some other auxiliary control surfaces, right? Which I will mention here. Some vortex holes will be provided either at the leading or you will find some time in the training is. These holes are nothing but vortex generators. Vortex generators. As I said, the lift depends on the circulation present in the system. So if vortex is present in the system, which will enhance the strength of circulation. When strength of circulation will be enhanced, there will be enhancement in the lift. So these holes kind of structure you are seeing. So the moment when air comes into contact with the holes will provide circulation over the top surface. So the moment the circulation is introduced in the system at the top, that means flow will become turbulent. So in turbulent flow, there will be more attached flow over the top surface. If there is more attached flow, and there is no lift. Usually, more circulation. Apart from this, some of the passenger aircraft you will find this kind of structure, right, situated over the wing. These are known as spoilers. Spoilers. So spoiler, by name itself saying it is going to spoil something. So it is going to spoil your lift. So during the landing time, we need the braking effects over the aircraft. We can use the spoiler, and we can use the spoiler for that purpose. So these are the different parts we look at from the top. We can find these all things. So if we come to the side view of it, right, particularly in the impedance section, right, here this is the horizontal stabilizer, right, as usual. This is horizontal stabilizer, right. This is known as vertical stabilizer. Vertical stabilizer, right. On vertical stabilizer, you will get a moving control surface, which is here, is known as a rudder. Alright, this is basically a rudder. So, rudder, this is also a control surface which will control motion of the aircraft. This will be a thing, the stabilizer to give stability, and those kind of concept will be controlled by this tail. So, at the tail, you will find basically these two things, horizontal stabilizer and vertical stabilizer, and all these components you are finding some control surfaces. If we look at the complete view, right, from the side view, it will be something like this. Aircraft will be something like this. Another name given to the vertical stabilizer, we say that is a fin. This is also known as fin. Right, fin. So here these landing gears are also very important part of the aircraft to support the aircraft on ground. So this is known as landing gears. So landing gears, there are three kind of arrangements: tricycle landing gear, bicycle, and tandem. Usually most of the aircraft use the tricycle landing gear arrangement, where 2 or 4 main wheels will be under the wing and one wing will be at the nose. In some of the lightweight aircraft or sports aircraft, you will find 2 landing gears just forward position of the wing and one small landing gear at the tail. And some of the passenger pusher kind of aircraft, you find this kind of configuration. Alright, that is called a tandem arrangement. So these, if you summarize, the main parts of the aircraft, usually we say fuselage, the central body to which all the parts are attached. Second one is the landing gear, which is required, landing gears, right, to support the aircraft. Third one, if you want to generate the lift, right, you need some forward motion. That motion will be provided with the help of aircraft engine. So engine will also, or engines, some of the aircraft will find more than 2 engines. Engine will also be the main important part of an aircraft, right. Then comes your main wing, right, which will give you lift, right, with the main wing. And then finally this portion that is called impedance, or you can say tail unit, right. This tail unit will control the motion, So these are the 5 main parts of the aircraft. Then further it will be divided into some more subcategory or subcomponents. Let's go for the subcomponent, right. So if we look at the primary control surfaces, primary means primary motions, how many it can create. So primary control surfaces are only 3, and I will tell you what all motions can be created by these 3 control surfaces. One is at the wing, right here you will find, that is aileron. Second, you will find at horizontal stabilizer, this is here, elevator. And third one you will find on vertical tail here, right, this is known as rudder. right? So these are the three primary control surfaces. Let's see their functioning, how actually they will work. So assume this is your aircraft, right? This is your aircraft, and here are the wings, right? One wing here, another wing will be here. The paired wing is known as the man wing. So the distance from one wing tip to the another wing tip is known as wingspan, usually wingspan. So now see, at the wing we are having aileron at the tip. So both side ailerons are there. So let's see the effect, right? So I am showing towards your side. So this is the nose, sorry. This is the nose of the aircraft pointing towards you. That's why this is one wing, another is wing is here. So let's move. Right wing ailerons is going up and left wing aileron is going down, and airflow is coming from this side. Now assume that the moment airflow is coming in contact with the aileron which is facing up, right? What airflow will do? Airflow will push the right wing down, right? Because it is directly striking over this aileron. So it will push the right wing down. But on the left wing, right, the aileron is down. So from downside a force will be acting, which will push the left wing up. So when left wing is going up and right wing is going down, in that case the net movement will be right, or we can say from your side anti-clockwise, from my side is a clockwise. So if I want to generate the clockwise movement, right, I have to put the right wing aileron up, left wing aileron down. So this aileron basically what is doing is doing rolling, right? So rolling will be controlled by the ailerons, right? So usually we say when right wing is going down or clockwise, rolling movement will be considered positive, and anti-clockwise rolling movement will be considered as negative. So ailerons are controlling the rolling. So rolling motion will be controlled by the aileron. Now next one is elevator. Elevator at the tail. So tail, let's suppose this is the tail, this is the nose, the tail, and here elevators are there. So let's suppose my elevators are going down. I am deploying my elevator down. Now as in airflow is coming from here, airflow will strike over the elevator. What will happen? It will push the tail up. When tail is going up, the nose will go down. Similarly, if I am deploying the elevator up, in that case, it will push the tail down, so my nose will go up. That means nose up and nose down movement is controlled by the elevator. So elevator will control this motion, nose up, nose down. Usually we consider nose up as positive and nose down as a negative movement. This movement is not, this kind of motion is known as pitching. Alright. So elevator will control the pitching. So pitching will be controlled by the elevator. Next one is rudder, right? Rudder is on the vertical tail. So let's assume this is the vertical tail, this is the aircraft. So my rudder is going to the right, my rudder is going to the right. What is happening? Airflow is come and strike over the rudder. When striking over the rudder, this will cause the tail to go to the left. Tail will go to the left, and what will happen to the nose? Nose is swinging to the right. That means, and vice versa. If I deploy the rudder this side, my nose will go down. So this kind of motion aircraft will be creating, and this motion is known as yawing. So yawing is controlled by the rudder. So yawing. So yawing or sideways motion will be controlled by the rudder, which is situated over the vertical stabilizer. At horizontal stabilizer, we are having the elevator. Elevator will control nose up and nose down. So altitude will be controlled by the elevator, and ailerons will control what? Rolling. So rolling will be controlled by the aileron. So these are the three primary control surfaces. So apart from these three primary control surfaces, there are some secondary control surfaces, or we can say auxiliary control surfaces. Let's see the auxiliary control surfaces. So if we look at the auxiliary control surfaces. So auxiliary control surfaces are nothing but which will give you momentarily change in motion, right? And it will be deployed only for some period of time. It will not be deployed always. So it will be deployed for some period of time. So auxiliary control surfaces, if you look at the wing, so wing inner portion you will get flap, vertex generator, spoilers, right? Sometimes slats, leading edge slat or leading edge flap also can be employed. Modified aircraft you are using the leading edge flaps as well. So these are all known as secondary control surfaces. or auxiliary control surfaces. So I will summarize here. Flaps, vortex generator, generators, if I say slats, right, if I say spoiler, so these are all auxiliary control surfaces. How do they work? So this is the thing. I said wing is responsible for creating lift. How actually is creating the lift? If there is attached flow over the entire surface of the wing, so when attached flow is there, more negative pressure generation will be there on top surface and positive pressure on bottom surface, and I will get the lift. Right. That will happen only when my aircraft is cruising. That means aircraft speed is increasing. So when the aircraft speed is increasing, if I am able to increase the effective area of the wing over which I should have attached flow, I can get even further increase in lift. How it will happen? With the help of flaps. So these are the flaps right in the side. So if I deploy the flap, effective, so the flap will be at the leading edge, trailing edge here. So if I deploy the flap will come like this. So if you look at the overall curvature, so curvature of the top surface has got increased. So when curvature has increased, that means there will be a more effective area over which I can have attached flow. So area over which I can have more attached flow has increased. Hence my lift will increase. So if I want momentarily increase in lift all of a sudden, right, I can deploy the flaps down when my aircraft is moving or cruising. The speed is increasing. Reverse effect is also possible if my aircraft is decelerating, right, during the landing. At that time, if I deploy the flap, what will happen? Already flow is already retarded because velocity has decreased. So flow may leave somewhere at 50%, 60% length of the airfoil, somewhere separation will happen. So if I am deploying flap, that means there will be a larger area of wake, right? Because wake area will be more. So when wake area is more, that means it's not going to help in the lift. That means what? It will increase resistance. So flaps can also provide you braking effects, right? When we are landing, at that time also you can deploy the flap to provide momentarily braking action on the aircraft to stop the aircraft within a shorter landing run. So flaps can be utilized for both landing as well as takeoff, right? To get momentarily increase in lift or momentarily decrease in lift. This is the one control surface flaps, right? Some of the passenger aircraft will get 2 or 3 flaps installed in the wing. Right. Second one is vortex generator. As I said, these are the whole kind of structures. Holes will be there on the top surface. Now when flow is coming, striking over the holes, through holes some mixing will happen, and due to which some small vortices will be creating over the top surface. So over the length, when they are traveling from one point to another point, those will mix up with the flow, and when mixing of the flow will happen, that will generate larger amount of circulations, right? All will jumble with a big circulation. So circulation in the system will increase. And when circulation has increased, right, there will be increase in lift. So momentary increase in lift can be generated with the help of vortex generators as well. But these are not beneficial at decelerating condition. We cannot use this. Spoilers, again, the name itself is saying it is going to spoil the lift. So these will also be working like brakes, right? When you are landing at that time, you can deploy the spoiler for some small time so that all of a sudden your lift will decrease by a certain amount, or you will get some braking effect on the aircraft. For that purpose, we use the spoilers. So how actually they will come out? So this is the wing, and over that, initially when they are not deployed, they will be flat, right, in line with the surface of the wing. So when you are deploying it, all of a sudden they will come like, and they will face the flow at 90 degrees. So the moment flow is coming like that, 90 degrees, and all of a sudden when the moment they are leaving the spoiler, right, flow will separate from that point, right? So flow is getting separated. That means there will be loss of lift. You will not get a uniform pressure distribution if we are deploying the spoiler. So spoiler will disturb the pressure distribution over the wing. When pressure distribution is getting disturbed, that means there will be loss in lift. So spoiler can also be used like to provide braking effect over the aircraft. So during landing we can use the spoilers as well. So these are all auxiliary control surfaces. Now question will rise how they are connected in the cockpit. So all are connected in the cockpit with the help of some mechanical linkage, right? So there will be some mechanical linkage which will be moving from these control surfaces to the cockpit. So let's suppose these ailerons will be connected with the mechanical linkage to the cockpit. There will be a stick. this kind of stick will be there, which will control the rolling. So if I roll the stick to the right side, right aileron will go up and left aileron will go down. In that case, I will get rolling in the right side. Similarly, if I turn the stick to the left side, left aileron will go up and right aileron will go down. I will get turning to the left side. So this stick will control. Similarly, elevator will also be connected to the stick. If I pulling the elevator backside, right, that means my elevators are going up, right? The stick backside, elevator will go up, I will get nose up movement. If I am pushing that forward, my elevator will go down. In that case, what will happen? Nose down movement I will be getting. So this stick kind of thing will be there in the cockpit. Similarly, this radar will be connected to the radar pedal. So if I forward the pedal, in that case I will get right turn. If I push backward the pedal, right, in that case I will get left side yawing. So this yawing will be controlled by the radar panel. So these are all connected by the mechanical linkage into the cockpit. So these are the primary control surface, auxiliary control surface. We have discussed all the anatomy of the aircraft. These are the anatomy of the aircraft. Now we go to the aircraft systems, right? As I said, there are three primary control surfaces. So three primary control surfaces we have discussed: aileron, elevator, radar. So based on that, we are going to define the axes. So if I draw the axis, so consider this is your aircraft, something like this. There is one axis going like this, right? This is your wing, and we identified center of gravity, which is somewhere here. So this is the position of CG, right? So if I draw a horizontal line, right, passing through the CG and going from the front of the nose of the aircraft and going up to the tail of the aircraft, right, passing through the CG, this is one axis. Second one, I can draw from one wing tip to the another wing tip passing through the CG. Third one, perpendicular these two, I can draw in this way. So like that, I can draw three axes, right, along the three planes, right. So one wing tip and another wing tip, if I connect those two, right, with the help of one imaginary line, right, that is one another axis, right, I will define that as lateral axis, right. So from one wing tip to the another wing tip, this axis is known as lateral axis. A line moving from front to the back of the aircraft is known as longitudinal axis, and a line passing perpendicular to both of these two axes and going to the CG position is known as normal axis. So these are the three axes of the aircraft. Now along these axes, three motions will be controlled and three motions will be happening. Now look at, I said, a measuring line going from front to the back, passing to the CG is called as longitudinal axis. And roll is happening about, you look at the roll is happening about what? This axis only, right? So rolling motion will happen about longitudinal axis, roll will happen about longitudinal axis. Similarly, pitching, if you look at the pitching is happening about a measuring line passing from one wing tip to another wing tip. So about lateral axis, this lateral axis, my pitching motion will happen. And yawing, if you look at yawing, is sideways motion is happening about this imaginary line, right? So yawing will happen about normal axis. Clear? Is that clear? I doubt on that. So three motions will be happening about three different axes, right? Longitudinal axis about that rolling, lateral axis about that pitching, right? And normal axis about that there will be yawing. So these are all imaginary lines, right, passing through the CG, and all are at 90 degree to each other, right? Like the three motions and three axes. So we can say an aircraft will have 6 degrees of freedom system. 6 degrees of freedom system. So aircraft is a 6 degrees of freedom system. So these are the simple funda of aircraft axis. How different motions can be possible. So now let's see what is wing. A lot of people are having confusion about wing. So if we look at the wing, particularly, wing is also an airfoil, right? So if we look at the wing, then it will be something like this. So it will have certain span, right, like this. So if I cut this wing from anywhere, if I'm cutting from here, if I look from this side, if I look from this side, I will get airfoil only. So this kind of structure I will get, and this cross section of wing is known as airfoil, right, or aerofoil. Alright. So it has certain span. So from one wing tip to the another wing tip, this is known as wing span, right? I will denote by small b. This is wing span, right? Denoted by b. And from one point to another point, this length is known as chord length, right? I will say c. C is the chord length. I will define it later on. Chord length. So the cross section of wing is known as airfoil. So airfoil, how will define airfoil? Airfoil is a specially designed body which, when kept at certain angle of attack to the free steel flow direction, it will generate a normal reaction which is known as lift. So now airfoil, right, can be of two types, right? Camber airfoil or symmetric airfoil. Let's see briefly about that. How do they look like? So airfoil nomenclature. Airfoil nomenclature. The definition of airfoil was given by the George H. Philip, an Englishman, way back in 1881. Right, and after that, a lot of experimentations have been done. There was an organization which is known as NACA, right? NACA. The former name of NASA, now it is known as NASA, National Aeronautics Space and Administration. Earlier name was NACA. NACA was earlier name like National Advisory Committee for Aeronautics. National Advisory Committee for Aeronautics. This was the organization which has conducted n number of experiments on different kind of airfoil shapes, and finally they come up with certain family of airfoil which we are still using today. And they have given 3 series of airfoil: 4-digit, 5-digit, and 6-digit airfoils. Some of those still we are using in the aircrafts, right, particularly passenger aircraft and fighter aircrafts. And the 6 digits is we are using in the wind turbine blades. These are all designed with the help of the airfoil shapes are given by the NACA. So NACA airfoils are the standards to which whatever new airfoils will be designed will be compared. Alright, so they have given the nomenclature of the airfoil. So airfoil, if we look at the detailed view of airfoil, which will be something like this. This is an airfoil. Alright, the front portion, this is known as leading edge, and this portion is known as trailing edge. Most forward point is known as leading edge, most backward point is known as trailing edge. Right, if we connect these 2 points, right, by a shortest distance line, right, this is known as chord line, and distance between these 2 points is known as chord length, or just chord divided by c, right, chord length. There will be another line, right, in between, which is known as mean camber line. Alright, between these 2 there is a difference, right? Certain difference is there. This is known as camber, this is upper surface, this is lower surface, right? And distance between upper and lower surface, this one is known as thickness. So one by one I will define that. Right. So mean camber line is the locus of all the point. This mean camber line is the locus of all the point midway between the top surface and bottom surface when measured perpendicular to the mean camber line itself. And chord line is the shortest distance between the leading edge and trailing edge. It's a horizontal line connecting leading edge and trailing edge. It is usually the shortest distance. It may not be inside the airfoil, sometimes it may be outside of the airfoil. Known as chord line, right? The distance between leading edge and trailing edge is known as chord length or chord, known by small c, right? Difference between mean camber line and chord line when measured perpendicular to the chord line is known as camber, right? And the distance between top surface and bottom surface, upper surface and lower surface when measured perpendicular to the chord line is known as thickness. So these are all the definitions were given by the NACA. Still we are using the same nomenclatures. If we look at the leading edge of the airfoil, it is circular, right? So it will have some leading edge radius, right? So this form leading edge is the center and this radius. This radius is also fixed. The radius is 2% of chord, 2% of the chord length. So leading edge radius will be around 2% of the chord length. This is fixed by the experiment, right? They have done the n number of experiments. Finally, they come out with this kind of design. They fixed the leading edge radius, which is 2% of the chord length. And this thickness will also be varying between 10% to 20%, depending on the type of airfoil. So these are the airfoil nomenclatures, right? Particular nomenclature. So we will be using this thing. Now come to the angle of attack. Particularly, a lot of people are having confusion about it. Right, so airfoil, let's suppose this is an airfoil. So if we look at the design of airfoil, top surface is having more surface, the bottom surface is almost flat. Right, so this is the chord length, or you can say chord line. Right, this is the free stream flow direction. This is the line, free stream flow direction. Angle between the free stream flow direction and chord line is known as angle of attack. So this is the angle of attack. Angle of attack. So there is a particular value of angle of attack at which if you situate your airfoil, you will get a normal reaction, right? Normal reaction, and one component of this normal reaction, like this, will be known as lift given by L, and another component is known as drag. This is drag. So this is alpha. This is also alpha. Right, angle of attack. So the component of the resultant aerodynamic force, this is the resultant aerodynamic force. The component of the resultant aerodynamic force perpendicular to the free stream direction. This is the free stream direction. Perpendicular to this one component we are getting, which is known as lift, and this lift will support your weight. The moment it is more than weight, your aircraft will be fully airborne. Drag is nothing but resistance, because it's acting opposite to the motion of the aircraft. Aircraft is going this direction, is acting opposite. Anything which is acting opposite known as air resistance or drag. Aeronautical terminology we say that is a drag. The component of the resultant aerodynamic force acting parallel and in the same direction of the free stream is known as drag. A drag is the penalty which we are paying basically to generate the lift. That cannot be minimized to zero, but it can be minimized to a certain extent by making your geometry more streamlined. As I already said that in the aircraft body, if you look at it, if you cut the nose and tail, you will get mid portion of the fuselage similar like airfoil. So all the parts which are facing the airflow, we are making it more streamlined like an airfoil. So in the aircraft, 90% of the lift is generated by the man wing, and remaining 10% there will be contribution from vertical stabilizer, horizontal stabilizer, as well as fuselage also used to generate some portion of the lift. That was 10% is all some components will be contributing to generate the lift. So this is the basic thing about the airfoil nomenclature. So today we have covered the anatomy of the aircraft. We have seen the primary control surfaces. We have also covered the secondary control surfaces, their functioning. We have seen the aircraft axis systems, and about those axes, what are different kind of motions, those also got discussed. Aircraft wing also we have defined what is the wing, right? We have seen the airfoil nomenclatures, right? And who has given this airfoil nomenclature? This is the NACA, National Advisory Committee for Aeronautics. Before 1952, NASA was known as NACA, now they became NASA. Alright. Now, as we are saying about camber is the distance between the main camber line and chord line. In some of the cases, there will be no difference between camber line. So, camber may be positive or negative. Keep in note the point. Camber may be negative or positive, right? It may be positive or negative. So, positive camber will generate positive limit, or negative camber will generate negative limit. In some of the aerobatic activities, we are using negative camber airfoil as well. Alright, in wind turbine blades particle, we are using the negative camber. So based on this camber, right, if there is a difference between main camber line and chord line, such kind of airfoil is known as basically cambered airfoil, and some books used to say unsymmetrical airfoil. It's not symmetrical. But if both the lines are coinciding, right, those are known as symmetrical airfoil. So these are the two categories of the airfoil: camber airfoil and symmetrical airfoil. Camber airfoil will have certain value of camber which may be positive or negative, or symmetrical airfoil will have zero camber. That means if we look at the symmetrical airfoil geometry, which will be symmetrical about this chord line. So chord line itself can be considered main camber line for symmetrical airfoil, but in the case of unsymmetrical airfoil, camber airfoil, there will be a distinguished difference between the main camber line and chord line. So today I am closing my discussion with this. Thank you for listening to my lecture. Have a nice day.